Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors Chapter 3, Quiz 1 Review Solutions on Rational Functions and Equations. To simplify this rational expression, I need to make sure there's no common factors between the numerator and denominator. Before I can do that, I need to know what the factors are. So factoring the numerator then, I need factors of -8 that add up to 2. So if we do 1 and 8, that's not going to work. 2 and 4 would work if you had -2 and +4. So x minus 2, x plus 4. In the denominator, I need factors of 28 that add up to 11. So 1 and 28 doesn't work, 2 and 14 is a bust. 4 and 7, that adds up to 11. So x plus 4 and x plus 7. Now that I've got things factored out, it looks like I have common factors of x plus 4 that I can cancel out. And I'm allowed to cancel these because if I wanted to, I could split these off into their own fraction and then just divide x plus 4 by itself to get 1. So now what's left over, we have an x minus 2 in the numerator and an x plus 7 in the denominator. To simplify by multiplying this together, it's a good idea to first factor and cancel out whatever you can, because you're going to have to do that eventually anyway, even if you multiply first. So in the upper left here, looks like I can take a 5 out of there. That leaves me with an x minus 2. And then in the lower right, I can take out an x, leaving me with an x minus 2. And at this point, I'd like to cancel a few things. These x minus 2's can be canceled. Now, even though they're in different fractions, we can cross-cancel them because the fractions are being multiplied, which means that if I multiply straight across, these x minus 2's are just going to end up in the same fraction anyway. So I can cancel those. And then the 4 and the 22 can be cross-reduced here. Those are both divisible by 2. 22 turns into an 11. This 4 is now going to be a 2. Let's multiply across now whatever's left over. So we have a 5 times 11 in the numerator. That's a 55. And downstairs we have 2 times x, which is 2x. To divide these rational expressions, very first thing I'm going to do is turn this into multiplication. So I'm going to multiply by the reciprocal of the second fraction. Same, change, flip. Keep the first fraction the same, change division to multiplication, and flip the second one so that the x squared plus 4x plus 3 is now in the numerator and the x squared plus x is now in the denominator. Now that I've got multiplication, I'm going to go ahead and treat this like a multiplication problem. Basically, factor and cancel everything I can, and I'm allowed to cross-cancel if I want to now because I do have multiplication. So factoring pretty much everything here can be factored. Let's start in the upper left. I can take a 6 out of that expression. That leaves me with an x minus 8. And let's go to the lower left now. I need factors of 48 that add up to -14. So let's see, we got 1 and 48, not even close. 2 and 24 doesn't work. 3 and 16 is better, but still not quite what we need. How about 4 and 12? Well, that's getting a little bit warmer. 6 and 8. Yeah, that adds up to -14 if I have -6 and -8. So we have x minus 6, x minus 8. All right. Let's do this upper right now. I need factors of 3 that add up to 4. Well, only one option there, 1 and 3, which happens to add up to 4. So we have x plus 1 and x plus 3. And down in the lower right, we can take an x out of that. I always look for common factors first. That leaves me with an x plus 1. What can we cancel now? Well, it looks like these x minus 8's can get canceled, and they're in the same fraction, so there's no question. But if they were in different fractions, I could still cancel them, because again, I'm multiplying here. We also have these x plus 1's that can cancel. Anything else? Doesn't look like it. So let me multiply whatever's left over now. In the numerator, I have a 6 times x plus 3, which I'll just leave that factored. And in the denominator, I have an x and an x minus 6 that go together. Doesn't look like there's anything else I can do, so this one is simplified. To simplify this expression, since I'm adding or subtracting rational expressions, I have to first get a common denominator. Now the good news is it looks like we've already got the same denominator. So I can just keep that denominator and then just add or subtract the numerators. So upstairs, I'm going to just rewrite things now. We have a 6x plus 14. And then I'm subtracting this whole numerator. So we got to be careful. I have to distribute a -1 to everything up there. So we have a minus 2x and a minus or plus 6. Now I'm just going to combine like terms up there, and I'll rewrite my denominator. So upstairs we have 6x minus 2x, that's 4x. And 14 plus 6 gives me 20, so plus 20. When you've added or subtracted, you should always double check to see if you can factor and reduce a little bit more, because you're not going to know it until you get to this point. It looks like I can factor a 4 out of that numerator. So we have a 4 parentheses x plus 5. And we might as well factor the denominator to see if there's anything that we can cancel there. So let's see, factors of negative 15 that add up to 2. Well, 1 and 15 doesn't work. 3 and 5 does if you have negative 3 and positive 5. So x minus 3, x plus 5. And lo and behold, those x plus 5s actually do end up canceling. So then we have a 4 over x minus 3. And now this is fully simplified. To simplify by adding these expressions together, I need to get a common denominator. Before I can do that, I need to factor my denominators so that I know which factors are going into the LCD. So the first one here, I can take out a 12, leaving me with x minus 2. And then for this other denominator, it looks like I can take out an 8. That leaves me with an x minus 2 there as well. For the LCD, that's the smallest thing that both of these go into. I'm going to start with the 12 and the 8, and I'll do the other factors separately. So I'm looking for the smallest number that 12 and 8 both go into. Well, does 8 go into 12? Maybe we already have the LCD. It does not. The next multiple of 12 is 24, and 8 does go into 24. So it looks like 24 is going to be part of our LCD then. Now let's deal with the other factors. We definitely need an x minus 2 included in there. And we also, well, actually there's nothing else. There's another x minus 2 here, but we've already covered it with the x minus 2 from the first denominator. So just kind of a quick guideline for LCDs if you're having trouble here. You're basically looking for the smallest expression that would cancel out each of the denominators. You're not trying to cancel out denominators, but if you wanted to, that's just kind of a way of thinking about it that gets you the LCD. And you only need more than one of these factors if it appears more than once in a denominator. Since the x minus 2 appears at most once in each denominator, that's why we only have x minus 2 here rather than x minus 2 squared or anything like that. Now that we've got the LCD, we're going to multiply each fraction by whatever it needs to get us this LCD in the denominator. So for my first fraction, I've already got the x minus 2, but this 12 needs to be a 24. So to get that, I'm going to multiply by 2 over 2. And I have to multiply by something over itself because I can't change the value legally of this. So I have to multiply by, I call it a fancy form of 1, a foo. Basically, just multiplying by 1 doesn't change the value. For this other fraction, I've already got the x minus 2, but this 8 needs to be a 24. So I'll multiply by 3 over 3 to make that happen. Let's actually multiply now. So 7 times 2 gives me 14 in that first numerator. Downstairs, I've got 24 x minus 2, which is what I was aiming for because we were trying to get the LCD down there. For the second fraction, 12 times 3 gives me 36 up there. And again, we have 24 x minus 2 downstairs. Since I now have the same denominator, let's keep that denominator and just add the numerators. 14 plus 36, that's going to be 50. And once you've added these, double check to see if you can reduce. 50 and 24 can be reduced. Those are both divisible by at least 2, I think. So that would give me 25 up here and 12. 24 divided by 2 is 12 downstairs. So when the dust settles, then we have 25 in the numerator and 12 parentheses x minus 2 in the denominator. Now, it might have been possible to reduce this second fraction at the very beginning, and maybe that would have helped us out a little bit more, but hey, we're here now, and we've got our answer. To simplify this complex fraction, I must first find the LCD for all of the subfractions within it. So let me go ahead and do that. Looking at my numbers for my mini denominators here, my subdenominators, I've got a 4 and a 6. Smallest thing that 4 and 6 go into, that would be 12. And then I also notice I have an x here in one of the denominators, so I need that in the LCD as well. All right, I'm going to go ahead now and multiply my main fraction by this LCD over itself. So 12x over 1 and 12x over 1 to be specific here. And I'm just multiplying really by 1. If you reduce all this, it's just 1. So I'm not changing the value, but this is going to give us a very useful makeover for this fraction. So I've got a 12x times the 12 over x, and I also have a 12x times the 9/4 minus a 12x times the 7 over 6. And the reason that I did the LCD is because that has everything I need to cancel out all of the denominators. So I'm going to go through and do that now. The x's up here are going to cancel, leaving me with 12 times 12, which is 144. Down here, the 12 and the 4 can reduce. That gives me a 3 over a 1. So 3 times x times 9, that's 27x. And finally over here, the 12 and the 6 reduce to a 2 over 1. So we have negative 2 times x times 7. Negative 2x times 7 gives me minus 14x. And one little step I can do at the very end, I notice I've got some like terms here that I can combine. So this subtracts to give me 13x. And there's no common factors between 144 and 13x, so this one is done. For this problem, we're trying to solve for x, and we need to beware of extraneous roots. So to deal with this rational equation, I'm going to multiply everything by the LCD, the least common denominator. That gets rid of the fractions and gets x out of the denominator. So the LCD has everything I need to cancel out all of the denominators. So I need a 9 and an x in my LCD. And now I'm going to multiply everything by that. By everything, I just mean the numerators. So we have 7 times a 9x up there. And we have a 3 times a 9x. And the 4 also gets multiplied by 9x. Got to do the same thing to both sides of the equation. Going through now and canceling some things out. These 9's are going to cancel there. In the second fraction, the x's are canceling. And now I'm just going to go through and clean things up a little bit. So in the first fraction, we just have a 7x left over. Next, we have a 9 and a 3, so that's 27 if I multiply those. And on the right side of the equation, this comes out to 36x. Let me subtract that 7x just to get all the x's together. So that's 29x. And then if I divide by 29, I have 27/29 for my answer. Just doing a quick check, if I plug this back into the original, I'm not going to get anything undefined, no zeros in the denominator. So that means that this is a good answer. To solve this rational equation, I want to get rid of those denominators as soon as I can. My strategy for doing this is going to be to multiply everything, at least all the numerators, by the least common denominator, the LCD. That's going to have everything in it that I'll need to cancel out all of the denominators. Before I can find the LCD, though, I do need to factor this first denominator to see what I'm dealing with. So numbers that multiply to 12 and add up to negative 7, that would be negative 3 and negative 4. So we'll have x minus 3 and x minus 4 there, which is mighty convenient because that's what I have in my other denominators. So my LCD then, that's going to have everything I need to cancel out all of these denominators, is going to be none other than x minus 3 and x minus 4. Now I'm going to multiply that by all of the numerators here. So this 2 is getting an LCD to join it upstairs. This x also gets the LCD up there. And this 2 also gets an LCD. It's a lot of stuff to write out. The reason I do that, though, is so I can see what's left over after I cancel things out. So in my first fraction, the x minus 3 and x minus 4 both cancel. In the second fraction, the x minus 3's are going away. And in this last fraction, it's the x minus 4's departing. Cleaning up what I've got left over here, I've got a 2 left from that first fraction. That's very satisfying. In the next one, I have an x and an x minus 4, so I have to distribute that. So we're going to have an equals that we don't want to forget, and we'll have an x squared minus 4x. Next, we have a plus and then 2 being distributed times the x minus 3 here. So that's a plus 2x minus 6. And I see that I've got a quadratic with just an x squared. So I'm pretty sure I can factor this if I get everything on one side. So let's see here. We have an x squared, and I'll just move everything over to the right side here. Negative 4x plus 2x is negative 2x. And then if I subtract this 2 over to this negative 6, I've got a minus 8. All of that equaling 0. And as I suspected, this does look very factorable. I just need numbers that multiply to negative 8 and add up to negative 2. So positive 2 and negative 4 will do the job. We've got x plus 2 and x minus 4. Equaling both of those to 0 and zeroing them out, I have x equals negative 2 and positive 4. But wait, before I just call it a day, I have to make sure these don't make the original problem undefined. So if I plug negative 2 into all these denominators here, I'm not going to get 0 in any denominator, so I'm good with negative 2. However, if I plug 4 into the x minus 4 here, I'm going to get 0 in this denominator. Since 4 makes the original undefined, we actually have to cross that off. That's an extraneous root, and only negative 2 is our final answer.